Verify if the functions satisfy the ODE or not. And here I say function because of this constant c. So the ODE that we have is xy prime plus y equals x, and the candidate function to solve it is y of x equals a constant over x plus x over 2, and this function we want to know if it works for any constant c. That's very common when you actually solve ordinary differential equations because a lot of the methods use an indefinite integral, meaning it doesn't have bounds. You end up with that plus c as the constant of integration. And here we go, so let's go ahead and find out if it works. So I have x, let's write out x times y prime. So I've got c over x plus x over 2 prime plus y, which is just c over x plus x over 2. And I want to know, does that equal x? All right, so the next part we should probably evaluate this derivative. So I have x times, all right, so let's simplify this a little bit. So this is c x to the negative 1 plus 1/2 x. All right, I'm going to write it out again. Right, x over 2, does that equal x? Oh, derivative. All right, so I have x. So the x to the negative 1 is going to pop down a negative 1. That becomes a negative c. And the decrement on the x power, so that's x to the negative 2. Then my plus 1/2 x just turns into plus 1/2 because the x turns into a 1. Then I still have plus c over x plus x over 2 equals, still not sure, x. Right now we can multiply through, so I've got a negative c. X times x to the negative 2 will be x to the negative 1 plus x times 1/2 is 1/2 x. Oops. I'll just say x over 2 plus c over x plus x over 2. Does that equal x? And yeah, it looks like it does. So I have the negative c here, x to the negative 1. I'm going to write as a fraction again. So it's negative c over x plus x over 2 plus c over x plus x over 2 equals, does that equal x? The negative c over x and the positive c over x cancel, and we're just left with x over 2 plus x over 2. And yeah, if I add those together, those will combine into 1x. So yes, this is a solution to the ordinary differential equation, and it's also an infinite number of solutions because it's going to work for any number c, from negative infinity to positive infinity. They'll all work.